Hello guys, today we will discuss about heteropolysaccharide, very important for biochemistry student and very important for various exams. Hetero mean different, poly mean many, saccharide means sugar. Mean the carbohydrate which are made up of different repeating disaccharide or monosaccharide are known as heteropolysaccharide. The carbohydrates which are composed of more than 10 monomers of different repeating monosaccharide or disaccharide are known as heteropolysaccharide. And it is very important for different exam point of view. Jean Loss, a scientist, has suggested the name of glycosaminoglycans. Glycosaminoglycans are also known as heteropolysaccharide or mucopolysaccharide. They are usually composed of two things. One, a minor sugar. It may be glucosamine or galactosamine or maybe acetylated form. N-acetylglucosamine or N-acetylgalactosamine. And with an acid, either glucuronic acid or hydronic acid. As a principal component, through some are chiefly made up of minor sugar and monosaccharide unit without the presence of uronic acid. Some do not have acid in it, but they are acidic because they have a negative charge due to the presence of sulfate group. The exosamine present is generally acetylated. They are essential component of tissue where they are generally present either in free form or they are combination with different protein. Actually, these hydropolysaccharide has negative charge and our protein have positive charge. So they are combined together to why ionic interaction. They are combined together by ionic interaction. Carbohydrate content varies when the carbohydrate content is more than 4%, then they are called as mucoprotein. And when it is less than 4%, it means they are called glycoprotein. Here we have an acidic form of glucose, which is known as glucuronic acid, which is produced during the oxidation of glucose at 6 carbon. With the carboxylic group and it is beta orientation. All mostly acid and minor sugar are mostly beta configuration. This is the most important concept about heteropolysaccharide. So this is glucuronic acid. If this carboxylic group is downward, then it is known as hydronic acid. So this is an acetylglucosamine minor group, then acetyl group. So it is known as an acetylglucosamine. Classification, although there is no agreement classification about the heteropolysaccharide, but they are classified into two categories. One is neutral, other is acidic. Acidic classified into sulfate-free and sulfated. So neutral are mostly present in the blood cells and cell wall of bacteria or some other microbes. One of the most abundant hydropolysaccharide is hyaluronic acid. It has a lot of uses. It has many uses. It is used as a lubricant agent in your joints. Sulfate-free mucopolysaccharide. It was first isolated from vitreous humor of eye. Eye solution is known as vitreous humor of eye. Later, where it acts as a lubricant agent. It also used in the operations of eye. Later on it was found to be present in salivary fluid, skin, umbilical cord, hemolytic, streptococci, and rheumatic nodules. It occurs both in free and salt-like combination. Why? Because hyaluronic acid has negative charge and salt has positive charge, like sodium and potassium has a positive charge, so it make ground ground substance with protein and salt. And it is an integral part of gel-like ground substance of connective and other tissues. Composition, it is composed of two things. It is composed of repeating unit of NH3 style glucosamine and D-gluconic acid. Both are in beta orientation. Both are in beta configuration. Mean N-acetyl glucosamine and gluconic acid are in beta orientation, which are linked by either beta 1,4, beta 1,3, beta 1,4, beta 1,3 glycosidic linkage. Function, act as a lubricant in your joint. Hyaluronic acid is in joint, act as a lubricant agent and a shock absorbent. Mean your all weight is beared by your joint because of this fluid, which is known as a lubricant hyaluronic acid. Intraarticular injection of hyaluronic acid in your knee joint is used to alleviate pain in chronic osteoarthritis of knee joints. If we have deficiency of this that hyaluronic acid, then our joint get have pain in it. Hyaluronidase and enzyme present in certain tissues, notably testicular tissue and spleen, as well as in several types of pneumococci and hematococci, streptococci. That's why that enzyme is known as a spreading agent, hyaluronidase. Because beneath our skin we have a layer of hyaluronic acid, and that hyaluronic acid is depolymerized by hyaluronidase enzyme, which facilitate the spreading of disease. That's why it is known as a spreading factor. Then catalyze the depolymerization of hyaluronic acid, and by reducing its viscosity, facilitate the free and material into the tissue spaces. Hence, the enzyme sometimes is designated as a spreading factor. Biomedical importance, the invasive power of some pathogenic organism may be increased because they secrete hyaluronic acid, which depolymerize the hyaluronic acid. In testicular secretion, it may dissolve the viscid mean complex substance surrounded the ova, which is mostly composed of hyaluronic acid, to permit the penetration of spermatozoa. So it helps in fertilization by degrading the hyaluronic acid present over the surface of the egg. Clinically, the enzyme is used to increase the efficiency of absorption of solution administered by classes. Classes, when we inject large fluid by injection, it is known as glycid. During glycid, we also use hyaluronidase enzyme. Then chondroitin is also a sulfate-free mucopolysaccharide or glycosaminoglycan found in cornea, has been isolated from cranial cartilage. Cranial cartilage or brain cartilage. It differs from hyaluronic acid only in that it contains N-acetyl galactosamine instead of N-acetyl glucosamine. Linkages are same: beta 1,4, beta 1,3, beta 1,4, and beta 1,3. Keratin sulfate, it is a sulfated heteropolysaccharide, mean mucopolysaccharide, found in the costal cartilage. This cartilage is your rib cage cartilage. And cornea has been isolated from bovine cornea. It has been reported to be present in nucleus pulposus and wall of aorta. What is nucleus pulposus? The fluid present in the central vertebra. Composition, it is composed of a disaccharide unit consists of N-acetyl glucosamine and galactose. It has two forms: keratin sulfate type 1 and keratin sulfate type 2. Total sulfate content vary, but ester of sulfate is present in carbon number 6 of both N-acetyl glucosamine and galactose. So both galactose and N-acetyl glucosamine have negative charge because of the sulfate group present on the carbon number 6. Linkages are same: beta 1,4, beta 1,3, beta 1,4, and beta 1,3. Keratin sulfate type 1 present in cornea. And why it is known as type 1? Why? Because it has N-glycosidic linkage. This heteropolysaccharide keratin sulfate make N-glycosidic linkage with the asparagine residue of protein on their N-terminal. Keratin sulfate 2, it occurs in skeletal tissue and it will make O-glycosidic linkage because this keratin sulfate attached with the protein through O-glycosidic linkage through serine and threonine residue. Then we have chondroitin sulfate. We have already studied about chondroitin, but chondroitin is mostly present in the chondroprotein, mean which protein which mostly made cartilage. There are 4 types of chondroitin sulfate. In type 1, which is present chiefly in the cartilage, adult bone and cartilage. What is the structure of type A? It is composed of N-acetylglycosamine and glucuronic acid. But N-acetylglycosamine is sulfated at carbon number 4 by making ester bond. Here you can see type A contain sulfate group at carbon number 4. Linkage are same, beta 1,4 and beta 1,3. Then we have type 2, mean B type, N-acetylglycosamine, and the difference is that glucuronic acid is changed with hyaluronic acid in chondroitin sulfate type B. And another difference with respect to type A, the one linkage is beta 1,4, other linkage is alpha 1,3. It is also known as beta heparin. Why? Because it has hyaluronic acid and as an anticoagulant property. So it is also known as dermatan sulfate beta heparin. Then we have chondroitin sulfate type C. Type C also contain beta 1,4, beta 1,3 glycosidic linkage. But the sulfate group in N-acetylglycosamine present at carbon number 6. In type A, it is present in 4. In type C, at carbon number 6. Type B is present in skin, cardiac valves, and tendons. Structure I have already told you. Then we have chondroitin sulfate. It has a sulfate group and carbon number 6. Then chondroitin sulfate type D, which is only present in the cartilage of a shark, mean fish. So its structure is simple with the type C, but the difference is that glucuronic acid contains sulfate group at carbon number 2 or 3. Then we have heparin. Heparin is also known as alpha heparin because it contains only alpha 1,4 glycosidic linkage. It is anticoagulant present in liver. It is also produced by the mast cell of liver. In addition, it is found in the lungs, thymus, spleen, valves of large arteries, skin, and small quantities in blood. Structure is very simple. It is made up of N-acetylglycosamine, and it has acid, either glucuronic acid or hyaluronic acid. Mostly 90% heparin is composed of hyaluronic acid as acid, and 10% heparin is made up of glucuronic acid. So one residue is N-acetylglycosamine, other 10% chances of glucuronic acid and 90% chances of hyaluronic acid. Linkage is same, alpha 1,4 glycosidic linkage. It is a highly sulfated heteropolysaccharide. Why? Because in acetylglucosamine or glucosamine we have carbon number 2. Mostly it is heparin contain glucosamine. Heparin contain N-acetylglucosamine. Heparin mostly contain glucosamine. So that glucosamine is sulfated at carbon number 2 and carbon number 6. And hyaluronic acid is also sulfated at carbon number 2, and glucuronic acid is also sulfated at carbon number 2. So it contains 3 sulfate groups. That's why it is known as a highly sulfated heparin, heteropolysaccharide. So epimerase enzyme present in your liver convert the glucuronic acid in hydronic acid. That's why the concentration of hydronic acid is very high. It is strongly acid due to high content of sulfate group. Molecular weight range of vary from 17,000 to 20,000. It occurs in combination with protein as a proteoglycan. It can either make N-glycosidic linkage or O-glycosidic linkage. The protein which attaches with heparin contain high concentration of serine and glycine. Mostly 2/3 ratio of serine residue which are present with the glycosaminoglycans. Linkage with protein molecule usually with N-glycosidic linkage or O-glycosidic linkage, serine or threonine. Heparin and antagonistic. The anticoagulant effect of heparin can be antagonized by strongly cationic polypeptides such as protamine, which is a basic protein, positive charge protein, which can bind with heparin. If it will bind with the heparin, then the inhibiting its binding to antithrombin 3. What happen in our blood? Heparin attach with the antithrombin 3 protein, which cause the dilution of blood, which inhibit the clot formation. But if we use protamine, that heparin does not attach with antithrombin 3. So what happen? Anticoagulant factor will be decreased. Clinical aspect: inherited deficiency. Individuals with inherited deficiency of antithrombin 3 have been reported who are prone to frequent and widespread. The people who has widespread clots in blood, they have deficiency of either heparin or they have deficiency of antithrombin 3 protein. Uses of heparin and heparin analog are used as anticoagulant. They are multiplicity of biological activities such as anti-inflammatory, anti-cancer, antiviral as well in the treatment of Alzheimer's disease. Heparin sulfate is low molecular weight heteropolysaccharide. It is produced during the infection of liver and light liver. Its structure is similar to heparin, but it is in acetylated form, N-acetylglucosamine and gluconic acid. It has one sulfate group less as compared to heparin. Neutral mucopolysaccharides do not have any charge like our blood group contain four neutral mucopolysaccharide mean lactose, glucose, and acetylglucosamine are lactosamine. If we have N-acetylglucosamine or galactosamine, then at the NAD using and then the blood group is A. If we have galactose at the NAD using and then the blood group is B, and if we have glucose, then the factor H is also present. We have already discussed the importance of proteoglycans. It is act as a constituent of extracellular matrix or ground substance. These are the functions of heteropolysaccharide. Interact with collagen and elastin to produce extracellular matrix. It acts as a polyanionic. It react with the GAGs react with the salt like sodium and potassium, and will increase the turgor pressure, and then will increase the osmotic pressure. Act as a barrier in the tissues. Beneath the skin we have a layer of hyaluronic acid, which prevent the disease by preventing the penetration of bacteria. Hyaluronic acid acts as a lubricant gel. It also helps in the release of hormones from granules like Golgi complex. Hyaluronic acid is also present in the embryonic tissue and help in cell migration and during morphogenesis and bond repair. If you like that video, please subscribe that channel and press the bell icon. Thank you all.